Hi there, welcome to my YouTube channel Prime Maths. In this video, I am going to solve a problem relating to testing of prime numbers. Here, it is given that n is a positive integer. For such n, one has to show that the expression 5 to the power 5 to the power n plus 1 plus 5 to the power 5 to the power n plus 1 is never prime. So, one thing is clear that we have to simply factorize the given expression into factors different from 1 and the expression itself. This is exactly the way to show something is not a prime. Let's see how this can be done. Before proceeding into solving the problem, let's see what the expression gives for a fixed value of n. For example, we have taken n to be 1. Using calculators, it is easy to see that the expression reduces to 18,571 for n equal 1. Now, with little effort, 18,571 can be factored into 17 times 1,103. So, for n equal 1, it is not prime. Now, we proceed for a general proof. At first, we will just simplify the given expression. Using simple laws of indices, it is easy to see that the given expression can be written as x to the power 5 plus x plus 1, where x is 5 to the power 5 to the power n. Now, see that if we can factorize the polynomial, we will solve our problem. See how a problem from number theory has been reduced to a problem of factorization of our polynomials. Now, for the polynomial fx, first, see that it is monic, that is, the leading coefficient is 1, therefore, its only possible integers roots are those which divides the constant term, which is 1. For this, we see the only possible choices are 1 and -1, but unfortunately, both of them fails to be the root, as f of 1 is 3 and f of -1 is -1. Now, if you're familiar with complex numbers, you must know that for the cube root of unity, 1 plus omega square is 0, and omega cube is 1. Using these results, it is easy to see that both omega and omega square are the roots of fx. The calculations are simple. We have already shown that both x minus omega and x minus omega square divides fx. Since both of them have no common factors, it means that their product will divide fx. But their product is simply x square plus x plus 1. Now, using polynomial division, we see that fx, when divided by x square plus x plus 1, gives x cubed minus x square plus 1. So, fx is product of these two polynomials. Thus, we have factored fx. Now, we simply substitute the value of x, which was 5 to the power 5 to the power n. Since fx is nothing but the expression 5 to the power 5 to the power n plus 1 plus 5 to the power 5 to the power n plus 1, we see that the expression factors into product of two numbers. Now, it is very easy to see that each of the product is greater than 1, which proves that the given expression is never prime for any positive integer n. If you find the video useful, don't forget to hit like, share and subscribe. Any suggestion and comment will be welcomed. You can follow us on Instagram and Facebook, @PrimeMaths. Thanks for watching.